Welcome everyone. As you're coming in, feel free to say hello in the chat. I'll stop the rotating clock in a moment here, but we'll get started. It's already at the hour. And we're so happy to see so many of you in here. I'm recognizing a lot of names. So welcome to our folks who are from libraries and noting they're in libraries. Thanks to those of you who are SciStarter ambassadors. I see a bunch of names. Hi, Jim. Hey, Mary. Hey, Heather. Hey, Keith and so many more. I will keep naming you as we move forward. If you are belonging to a library, please go ahead and add your library name to the end of your name on Zoom. You can click on the, let's see here. I believe you should be able to change your name. It's in your settings on the Zoom menu. So I will give you lots of time to do that. It'll matter later on. So if you're coming in from uh, a satellite location, we'd love to see where you're coming in from. All right, we'll go ahead and move forward and start talking. So welcome everyone. So you're here to talk about what's the weather like on Mars. This is an Axis Science Connected event. We are so glad to have you here. There's people from all over the place. I've been seeing the locations just coming in. Feel free to just add in where you're calling in from. I see a lot of other countries and a lot of states in the list. So welcome, welcome. And Access Science Connected, just to give you some understanding what this is the idea that we are everywhere. We have locations across the country joining us to work together to do science together. We'll be talking through a project in which you're going to look at Mars and the Martian atmosphere. And we're all going to work on it together to get more and more acts of science into the test tube of Citizen Science Month. And what I mean by that is this month, this entire month, we're looking to get as many classifications, observations, all kinds of activities that are citizen science participation in real research, up to 2.5 million or past that by the end of the month. And so we're really grateful to have you here to make one big collective impact together and get you started as soon as possible while we continue to chat for the next 2 hours. We have an awesome team with us today. So I'm from the SciStarter team. My name is Emma. I also have with us Roland Moundelock and Darlene Cavalier. Darlene is the founder of SciStarter. She's waving right now, and she'll also come in to chat with you later on. Roland is your support in the Zoom chat, as well as Sarah Marcotte. So Sarah here is with us from the NASA Solar System Ambassador team, also with NASA JPL, and she'll be helping us answer questions that you have. And along with her, we have a couple of solar system ambassadors in the chat already who are our moderators because they are super experts in all things science related to NASA. So if you do have questions, you might see someone answer who is a solar system ambassador. So just look out for a bracket that says moderator. If they respond to you, that's them. And excited to have them on board. Thank you all for being here to do that. All right, and lastly, we also have an awesome team with us today. This is the NASA JPL team behind the project Cloud Spotting on Mars, which is our topic of today. And so while we push the mic to them in a little bit, we'll be talking about how they can teach us how to help them find all the clouds on Mars and contribute to Martian atmospheric research. Fancy terminology. So as you have questions throughout this entire thing, we would love to hear them. You are welcome to use the Q&A to answer or to ask questions that you want answered verbally. We'll keep an eye on that. And you can also upvote them. So you should be able to hit the button to say, oh, that's a great question. Let's make sure that gets prioritized. You can also use the chat. As I mentioned, the moderators who are in the chat will be able to help with small things. And we'll push you to add to the Q&A too, as needed as well, or they'll add it on your behalf. Just a reminder that we're here to have a lot of fun and have really awesome conversations. And so keep it relevant, keep it kind, and we're just going to have a great time. So keep that in your brain that you will be able to add things to the Q&A and the message or the chat, excuse me. All right. With that, I want to do one last push for anyone who is doing a satellite event, which means you are showing this in a group of people with you. We would love to know where you're coming in from, so feel free to drop it in the chat. You can also select your name from the participant list, thank you, Amani, to change your name to add in that satellite event. This only applies for those who are those libraries or third spaces who are hosting satellite events and are moderators. All right, those are the only weird names you'll see in here. Okay, cool. Awesome. All right. Glad to have you all in here. I'm going to go ahead and pass the mic over to Merrick, who is going to be speaking to us first. Just to back up a tiny bit, we got two of our folks joining us. We have Merrick Slipsky and Armin Kleinbuhl, and we will be talking to them because they're the project leads of cloud spotting on Mars. Armin is the principal investigator of the Mars Climate Sounder instrument, which you'll have to tell us more about, on the Mars Reconnaissance Orbiter. And Merrick is the co-investigator. Both are scientists at NASA's Jet Propulsion Laboratory in Pasadena, California. And with that, I'm going to pass it to Merrick to give us a good opener as to what we're going to be looking at today.
Hi, everyone. If you look out your window right now, you might see clouds in the sky. And similarly, our rovers on the surface of the red planet often see clouds on Mars when they look up. In cloud spotting on Mars, we use observations from orbit to find Martian clouds.
Awesome. Yeah, and this image, I love this image because it makes you feel like you could literally just be in the desert on planet Earth. But this is from Mars, is it not?
Yes, this is from the Curiosity rover on
Awesome.
Mars.
Yeah, and we'll be looking at more pictures of the Martian clouds later on as well. So, can you tell us a little bit? So, we're going to jump to learning how to do this in a moment, but can you tell us a little bit about the imaging that we're going to be looking at today?
Sure. So all the images you'll look at in this project will look something like what you see on the screen. This is a simple example, but what you're looking at is data from the Mars Climate Sounder, which is on the Mars Reconnaissance Orbiter at Mars. So the Mars Climate Sounder looks at the horizon of the planet from orbit. And what you see here is sort of brightness of the atmosphere over a couple of orbits. So we go over the pole onto the night side, we come back over the south pole onto the day side, back onto the night side again. Um, and you can kind of see this brightness in the lower third of the image, which is the lower atmosphere. But what we're looking at in this project are these arch-shaped features that show up. And the peak of that arch is actually a high altitude cloud. So the goal of this project is to identify those arch peaks in images like this, which are about 4 hours in time on the horizontal and from the surface to about 100 kilometers up in the atmosphere. And as we find those, we can start to categorize them and look at their distribution across time.
Awesome. And I've been playing this, I'm going to call it playing a game, but playing this Cloud Spy on Mars activity um, for a while. This was actually one of the first projects I did as a citizen scientist. So I'm excited for everyone to be able to see just how easy it is to really get involved in these things. And it's involved, right? Like we already have another project related to cloud spotting on Mars as well, which I'll actually show at the very end for anyone who's like, yes, give me more. So assuming that many of you would like to participate, why don't we go ahead and get you all set up and show you what it looks like so that we can get you rolling and you can participate for as long as you want throughout the full 2 hours and way beyond that as you'd like. So I'm going to shift my screen just so you can see what you will be looking at. So this is the Zooniverse platform that is hosting this project. Our colleague Roland here is going to be dropping into the chat the full instructions, and I'm actually going to walk you through how to do this. But when you get here, please note that you have a nice tutorial sitting here. So when we get to this point, you'll also be able to go through tutorial on your own if you'd like. But these are the types of images you'll see. Now, looking at this with very fresh eyes, I wanted to look at this one as our first example so you can see some instances of clouds that are kind of hiding in here. So Merrick, where should I be looking first?
So if you want to jump back even to the first of the four images there, so at the bottom you'll see these thumbnail images. So we're showing the same data but with different contrasts. So as you sort of move through those, uh, uh, you'll see you'll see the image get brighter in certain regions. Um, and the goal again is to find these arch peaks. So there's only one identification tool, this arch peak marker, and the goal of this is to put one of those at any of the arches that you see. Um, so yeah, sometimes it can be difficult, and you'll notice this one's a lot more complex than that simple example. But it is that arc shape that you're looking for in every image.
All right, so I'm looking around to see if I can find some. And those arch, I really like the training for this tutorial because it mentions like the idea of legs and a peak, right? Is the that nice way to identify it really if it really is an arch. And so in my mind, the most clear is over here. Would I be in the right?
I I think that's one that yeah, that's a little tricky because it's very narrow. Yeah, so it's a good opportunity to show that zooming in on these and looking a little closer can help. And I agree. I think that's one.
Okay.
Um,
Yes. Got one. And I'd mark it at the top of it or near the top of where I see the legs connecting.
Yeah, this is a little tricky, but don't worry too much about exactly where you place that. We have some tools that use the output of everybody's marks to kind of fit that together a little easier.
The
Um,
power of the crowd.
yeah.
Any else in here that you would want? Oh,
Yeah, I'd
is
say
there
jump to
more?
the fourth panel, and then those ones you're looking at right now will really pop out. Yeah, there you go.
Whoa, look at that. Huh. Okay, cool. So I might be marking one here and maybe here, or is that too vague?
Yeah, I think that bright spot a little bit above where your cursor currently is. Yeah, so it's hard to see the two legs. You definitely see one on the right side of that. And the
Hmm.
left one I think is there. It kind of hides behind the brighter data below it. But I agree, that's an arch.
Awesome. Okay, so this is only looking at half the image too, so I know that there may be a few over here. But since you've seen this in your screen as an example, now I feel like you guys might be very interested in joining us. And so for guided practice with us and doing this together, I'm going to make sure that we have all the setups first to make sure it all counts towards our goal for Acts of Science today, and so you can continue on your own later. So before we continue here, I'm going to swing us back. And I do see some of you might already be working on this. So if you're already familiar with this project, run wild. Go for it. Feel free to answer questions in the chat or tell us when you have a difficult one, because we'd love for you to just do as much as humanly possible during the time with us, while you have a moment to talk to the project leaders too. So I'm going to click forward. There is a video instructions piece for you. So you can scan this QR code. It'll be up here for the whole slide to get these via video. So if you would like to look at it as a video, you have that for you. I'll also show you where to find these instructions beyond when I have it on the screen for you. So you can always take more time to do this. But to make sure we all feel comfortable getting started, here are those steps. So our first step, which Roland, would you mind dropping back in the chat for us again? Step number one, we're going to create a SciStarter account. Why do we do this, do you ask? I will explain momentarily. Once you've done that, you can create a Zooniverse account as well. So Zooniverse and SciStarter are partner platforms. And during Citizen Science Month, we're trying to make sure we're counting as many acts of science, which in this case, how many classifications of data of images from the Mars research we're going through. And so, as much as we'd love to just pull all the data, this means we can identify how many folks are participating during these events. And so, Zooniverse and SciStar are partnering up. We create accounts on both to then connect them through a digital link to be able to count all those acts on SciStarter's side. And I can talk more about that and actually show you it happening later, which will be really nice. So once you've made both accounts, you are also going to be adding your Zooniverse username to your SciStarter account. This is what sets up that digital link. So once that's done, all of your work on Zooniverse for any SciStarter affiliate project that is on Zooniverse, which is many, will be added to your dashboard so you can see what you're doing over time. It's a nice way to track like your volunteer hours and your the effort you do for various projects. And so you can do more than just what you're doing today, essentially. So to do this, you're going to take that username on Zooniverse, copy and paste it into your SciStarter settings. So I'm going to pause on these instructions right here to actually show you what this looks like. So on my account on Zooniverse, I'm going to go ahead and sign in. And my username was right there, EC Giles. And so on SciStarter, I'm going to visit my profile. or my account in general. And then when I go to info and settings, I have all this information about myself. I'll skip so you don't see all of it. And then at the very bottom here, I've added in my Zooniverse username incorrectly so that I can show you what it looks like when you write it incorrectly. EC Giles. And then I save. And then that's the one thing. I only have to do it once. It'll work for all these very varied projects down here. First one we listed was Clouds by Mars because we love it so much. Or it might be in alphabetical order, but that's okay. So all these projects will track too. So if you love this and you're like, I want more, you got more. All of that. All right. All my information is saved, so I'm going to go back to Zooniverse. And now that I have added my project, or sorry, added my username, I'm good to go. However, you don't necessarily end up on this page like me. You might be looking at Zooniverse entirely. So just so you know how to navigate, you can click on projects at the top left here, and then you can search for it. So we're talking about Mars. Let's see if Mars will pop it up. Pop. I know cloud spotting will. I didn't actually hit go either, so that probably is part of it. There we go. All right. As I mentioned before, it's evolved. There's a shapes one. We're going to be doing the regular cloud spotting on Mars one today. All right. We also, just a note too, if any of you are looking at the chat, there's more information from SciStarter's founder. If you'd like to read more about that, it's only once that you have to do this, and it takes very little time, as you noted from my creation of that digital connection. All right. This also means, yeah, that's a good point. So you'll also be eligible for prizes, badges, certificates if you're registering your participation through SciStarter. So please do this so that we can make sure that you're in the list, you're in the running for prizes at the end of Citizen Science Month. Yeah. Oh, good question. So we didn't talk about this, but Zooniverse does have an app. We're doing this on the desktop. I would recommend doing it on the desktop. Merrick, can you tell me if I don't think cloud spotting is on the app, but I don't recall.
I actually don't know.
Oh,
I know you can still do this in a web browser on a phone, but I'm not familiar with the app.
okay. Yeah, I haven't used the app either, although I know for some projects it's really easy because it's like a one thing. You just pass it to the left or the right. But I don't think, yeah, okay. So our friend in the chat is telling us it's not there. Yeah, so if you're on a phone, make sure you're going to your web browser like Safari or whatever it might be on your phone, to then go to zooniverse.org. Okay.
Yeah, in general, I think it works better on a tablet or a laptop because the screen is a little bigger and we're looking for fairly small features in a big
Mhm.
in a big set of data.
Yeah, definitely easier when you're looking at it under with a giant screen like I have in front of my face. But we don't always have that. If you're on a phone, you can still definitely do it, but just be aware that you might have some trickiness to work through. I did see a question about finding the project, so I'm just going to demonstrate one more time. So if you are on Zooniverse, just the plain old website, I can click on projects at the top left menu. And from here, you got all kinds of things. So you can check out other ones later. But from here, it says search projects, and I'm going to search cloud spotting. Okay, good. Yeah, try the cloud spotting word. It likes it for the first word of the project for sure. Okay, excellent. All right. So for any of you who are not looking at this from being within Zoom with us, like if you're looking at a bigger screen from your library posting this in front of you, you might not be following the steps that are in the chat, for example. I'm going to show you where you can find those steps. So aside from in front of you here, scanning that QR code, we also have ready for you at any point during this time. If you go to scistarter.org/blog, just scistarter.org/blog. This first link has all the links, including the instructions and more for the rest of this event. And this is for anyone who's tuning in with us. I'll go ahead and drop that link in the chat for you. Oops. And make sure you're sending messages to everyone in this case. SciStarter, Sci as in the beginning of science, and then starter.org as if you're starting something, /blog. And when you jump there, yeah, JT, you can also find it from SciStarter, but it'll take you to the same place. Yeah. So if you search SciStarter, it'll give you that link. Ooh, good question. Desmond, we will be right there. I want to make sure I read that before we come back. Armin and Merrick just handing you a note there. There were some questions that were coming in the chat that we'll answer momentarily when we get back to the project. Can there be arches within other arches? If there were any other questions, Sarah, my friend, I'll be asking you about them shortly. If there were any others. Okay. Cool. All right. If we're feeling great, if you're on Zoom with us, I would love a thumbs up from your account. I believe there's a reactions button that you can hit. Feel free to give a thumbs up if you are able. I see some hands raised. That's also an option. Awesome. Oh, and I have a few of you to mark as moderator. Welcome, moderators. All right, I'm just giving a little bit of pause so that you know where you are. All right. Okay, I'm gonna go ahead and move us forward and start the project. So if you're signed up and ready to go, there's a tutorial for you if you want to rush ahead, but we'll go ahead and do a bunch of practice together too. All right, cool. Oops. Let's visit Classifying on Mars. And then once you're here, by the way, I didn't take you straight to the classify page yet, but you can do so right there. And we'll go ahead and get started. Merrick, at some point, or Armin as well, actually, at some point, I might have you actually share your screen for us. But I'll let you know when that might make the most sense. As we get started, it might just be good to have you narrate through a few. All right. Cool. Okay, so let's take a look at a first example. I'm actually going to refresh. If you ever get stuck, by the way, and you're not sure, you can always refresh to look at a new one. Armin, should I stay on this one? What do you think?
Sure, we'll give it a shot. Maybe
All right.
maybe look at the ones with the higher contrast.
Sure. Okay, so I'm looking through the other ones to see if it helps me see more.
Yeah.
How do you feel about it?
Yeah, I'd say there's a couple, aren't there?
Okay, these ones seem tougher for me to see, so I would love your thoughts on your process for finding them. What do you look for first? Oh, Heather knows where to find them.
Well, I guess we typically start looking for arches in the, in the darker images, that shows us the brightest ones. This is all fairly subdued, so probably like the stronger stretches might be more helpful, either the third or the fourth stretch.
Third or the fourth image? Sorry, when you said stretch, do you mean section of the image?
Stretch is like the brightness stretch. Yeah. Here you see quite a few already. If you look at the left-hand side of the picture, you can see two sticking out pretty clearly, I think. So these are
totally.
candidates that I would definitely mark.
How's that for location? Look good to you?
Yeah, this looks pretty good, right? There's like one next to it.
Oh. All right. So can you remind us too? So when we're looking at arches, now that we're set up, I want a quick reminder of like what this what the image is actually representing. So I know this lower section as it gets brighter is the lower atmosphere. Is that right? So how are the clouds coming above, or am I misunderstanding?
Yeah, the feature of this measurement is that it looks across the horizon. So we're not looking down on the surface; we're looking across the horizon from Mars orbit.
Mm-hmm.
And we're looking for these images. We're looking in the direction of spacecraft travel. So we're looking in the direction the spacecraft is flying towards. And when you have a cloud, sitting somewhere in the sky, it looks like it rises and sets as the spacecraft gets closer to it and eventually flies over it. And this is what gives these clouds the characteristic arc shape that we're looking for in this project. So it's really the clouds don't have an arc shape by themselves. The only feature is they're sitting fairly high up in the atmosphere, so they not get swamped by dust that's below in the atmosphere. And they are laterally confined. So when the spacecraft flies towards them and over them, the geometry gives the image this kind of arch shape that we're looking for.
Oh, okay. I'm trying to picture that, and it's a little, or I'm just like trying to picture being a moving orbiter. I'm trying to figure out how that's,
I think there are a couple of
how you
sketches
take pictures
in the
like that.
tutorial. If people are interested, they can pull that up.
Yeah, and certainly in the about page too.
Oh, there we
Yeah,
go. That's very cool. So why do we care about this? There was a question in the chat that is so important I was going to go to next too is like, why do we want to know where they all are, I guess, or how do we not know where they are based on this data yet?
So, so these are two questions. How do we not know? Um, could you repeat the question?
Why do we want to research this?
Um, I don't. Shall I take a stab at that?
yeah,
I think clouds in the atmosphere of Mars are very interesting. They can tell us a lot of things about the atmosphere, especially in the Martian atmosphere. The Martian atmosphere is fairly cold, and it gets cold enough to condense out the main constituent of the atmosphere, which is carbon dioxide. So we can form clouds that are essentially made of dry ice. That's something that we don't have in Earth atmosphere. So so the occurrence of those clouds, if it's CO2 ice clouds, they can tell us something about the structure of the atmosphere, certain atmospheric dynamics that might foster the formation of clouds. And then it tells us something about the cloud physics itself, how these particles form. Once they form, they have a certain weight, they will fall down in the atmosphere. They might fall into regions that are warmer and then sublimate again. So so it tells us something about the cloud microphysics too, if we look at that in more detail. The other kinds of clouds that we might find are water ice clouds, and and that is interesting for a bunch of aspects, especially as Mars Climate Sounder doesn't measure water as a data product. So if we have water ice clouds, then it tells us that hey, if we have water ice clouds, then there's water vapor also in that region of the atmosphere, and that's interesting, especially if it's very high up in the atmosphere. If you have water very high up in the atmosphere, 60, 80 kilometers, that's high enough for the solar radiation to be very intense. So the solar radiation can then like split up that water and form hydrogen and oxygen. And hydrogen is very light, so the hydrogen can move farther up into the atmosphere and eventually escape to space. So so this is actually one of the mechanisms that we're looking into very thoroughly, to see whether Mars might have lost its water over long periods of time, geologic periods of time, um, by that
Because of
process,
that. Yeah.
and hence the planet got drier over geologic periods of time. So
Mhm.
so having information of where this water is located in the atmosphere is really important for looking into that question.
and I'll just add
Yeah.
one more aspect to this to bring it back to Earth a little bit. So if you're thinking about weather and climate on Earth, clouds are actually a big source of uncertainty when you're trying to run these large simulations. So the properties of the clouds on Earth, whether they're thin or thick, where they are on the planet, right? If you look at a picture of Earth from orbit, it's going to look different every day because those clouds are in different places and have different features. And all those details are important for whether clouds how clouds influence the atmosphere. So they can both reflect the incoming light from the sun, but also absorb and re-emit infrared heat from the planet. So whether they're heating or cooling kind of depends on the details. And so we run simulations like that on Mars too. We want to know where they are and what they're made of so that we can do things like predict the weather and climate.
So we're basically the first ever meteorologists of the Martian, of Mars.
maybe the first, yeah, large number of citizen scientists.
Yeah, many, many of us. Probably not as exciting a data point if it's one of however many volunteers you have. But I still like to consider myself a Martian meteorologist. Would be pretty cool. So, does this have anything to do with what we might end up like needing if we try to transport ourselves to Mars? There was a question related to that in the chat. Any
I think
thoughts,
so.
Tracy? Yeah.
Yeah, I think that is kind of what I was getting at with the last answer, that when you want to do things like predict weather
Mm.
every day, or know how the climate is going to change year to year, clouds are an important piece of this. And um, uh, it's it's useful here to get this large data set so we can map them in space and in time, and see how they change year to year. So when we started this project, we actually didn't expect to even get a full Mars year of data analyzed, but we're on our fourth now. And so what we're hoping to do is look for changes during different years, because Mars has different conditions year to year. Sometimes it has more dust in the atmosphere, sometimes less. Um, so by identifying these clouds across different years, we can start to see uh, uh, changes between individual Mars years.
Wow. That's pretty cool. Pretty
I
cool.
see another couple of interesting questions. Can I ask those, Emma?
Yeah, go for it.
Excellent. So people are, a few people are asking, from comparing conditions on Earth and the clouds that we're familiar with on Earth. So are clouds on Mars categorized in things like cumulus, stratus, that sort of thing?
That's a great question. Yeah. Do you want to take
Yeah,
this?
the atmosphere of Mars is very thin and it doesn't have that much water vapor. So most of the clouds are kind of like fairly tiny, wispy clouds, kind of like they're more like cirrus clouds on Earth. That's probably a good comparison. Another good comparison is very high altitude clouds that we find in the summer polar region Mars, in the upper mesosphere, like at 85 or so kilometers altitude. These are very waterized clouds that are made of very, very tiny particles. So that's probably also a pretty good comparison to clouds on Mars that we can see.
Yeah, and just to reiterate that, like, one of the major differences between the clouds on Mars and Earth is that all of these clouds we're looking at in this project on Mars are ice clouds. Some are water ice and some are CO2 ice, but there's not going to be any water droplets compared to on Earth, where almost all the clouds are water droplets.
Well, it's water and ice, or
Mixed, yeah,
mixtures of
you
it.
get,
Yeah.
yeah, mixed phase
We've
clouds,
got
but
complexity. Sarah,
Oh,
before we move forward, I did want
sure.
to finish out this classification so we can get people on a leaderboard too. So before we answer more of your many awesome Mars questions,
Sounds
let's
great.
go ahead and close out this one and then maybe look at another one before I show you, or we'll have the leaderboard link for you all if you would like to see how you do compared to everyone else in the room. So my friends who are in the chat, some of you had some great answers to this classification. Do you think I'm done? Or should I be answering more or looking for more? Heck. Are there more in this image?
Um, well, there are a couple like in the center there or one. I would mark those.
Over
There.
here?
Yeah. What about these guys? I can see some peaks. I can see some legs. The legs are a little blurry, but I think we still can see them. So I would mark those.
Yeah, so when they are blurry like this, that does like would you say that it's more common for people to give it the benefit of the doubt of being arches if it does have this blur, but it's kind of there?
If you still can see something that's, like a darker spot in the middle, I would probably mark that. Yeah.
The
yeah, and
darker
what
spot in the middle.
so for
Where you have the bright peak on top, and then it's
Mhm.
darker below, and then a little lighter color to the left, to the right, kind of thing.
Yeah, I totally agree. If you go back to where you were just looking with those two, so yeah, this bright spot above is pretty clear. So that's where maybe my eye would go first. And then what Armin's saying is look a little bit down to the left, a little bit down to the right. If you see some brightness there, and then a dark patch in the middle, so like a gap between those two legs coming off the bright top part.
And they
And you're
have to be
not
like
always
aligned with the bright, or does it
yeah,
depend?
the legs that kind of make up that arch. Where if that's all filled in with brightness, then I wouldn't say you can see the gap, and so I maybe wouldn't mark the arch. But as long as you can see those legs starting to come down, and I think in both of these that you marked, it's not just that bright spot. There's a little bit to the left, a little bit to the right, and it's definitely dark in between those left and right bright spots.
Awesome. Okay. What about over here? We have a giant white spot here, but it looks a little too intense for me to be automatically like, yep, that is it. Maybe it's something else going on, but that might be crazy too. Like, is this when it's kind of an extreme and kind of off to the right, does that
Yeah, kind of a tough
classify
one,
as an
isn't
arch?
it? It has a
Yeah,
bit of different geometry too, sort of like,
I, I would probably mark that. I would maybe check one frame, one stretch backwards.
Ooh,
oh yeah,
Yeah.
there, there it looks
intense.
not as saturated. Yeah.
What's probably happening in that last one is that we're stretching it so far, we're getting a little bit of noise around the peak of that arch. But I think those
Oh,
legs are pretty clearly there.
yeah. Okay, cool. I feel good about that one. Am I missing any in this area? Checking the chat in case anyone has a opinion on this before I moving a little bit. Ooh, that seems
This
interesting
guy,
to me.
maybe it's kind of like at the edge a little bit, but I would probably
It
mark
makes
that
me
too.
happy to hear so many maybes from the actual scientists. That is one thing that I had to learn was like, don't panic about making errors in citizen science. A lot of these projects on Zooniverse and all of the above citizen science projects include quality assurance and like they know that you're not an expert in this. And so, can people feel okay about making guesses, generally speaking, if
Yeah,
moved?
I think when you hit those first ones you're not sure about, it's a good time to check out the field guide. Um,
Ooh, good call.
uh, and uh, take a look through some of those, especially uh,
Yeah.
yeah, just try to compare some of the images in these to what you're looking at and then read the details. We've tried to walk through some examples where things look really close. They look like arches, but probably aren't. And, some of this text should help you make those decisions as you go. And that means you're hitting the complexity of the problem, and you're getting a little bit more subtle about these distinctions.
Yeah. You get better as you go, as you see more of these. And a reminder if anyone is like, I can't answer this, I'm just simply not sure about this one, refresh your page. You are allowed to do that. Awesome. Okay, now I'm gonna go ahead and just double check with my team here. Can you tell me if I'm missing any so we can get folks on the leaderboard and we can answer more questions? Mm, I'm feeling iffy about
Definitely
this.
a candidate. Yeah.
Oy, oy, oy.
Yeah. This
Maybe it
is,
looks like it shifted off to the left though. Does that matter? Ooh,
I would say this is a candidate, the one that you just had. Yeah. Yeah.
this guy?
Yeah. Yeah. It's a bit in the same category as that one, the one that we had previously that's at the edge of like one of these bright areas.
Okay. How do we feel about this section? Because it looks like there's dark, but it doesn't look super bright at the top, so I'm not sure if they're actually connected. But I think they are.
Yeah. And that stretch it looks like. Yeah. I would mark that too.
Me too. Yeah, I think that looks good. Yeah, and one
Green.
while you're kind of looking through the last of these, one tool that a lot of participants have told us they like is
There's
uh
another candidate
the
here, right? In that, on top of that bright area there, there's like, yeah, there's a couple,
yeah, that's kind of going up.
right?
Yeah, the color
Like they're really
inversion
tall. Oh, color,
right
like,
above the field
oh, this
guide.
guy?
Yeah, some participants really like to use this inversion instead, or flip back and forth between the two.
This area is giving me pause, but it looks like a lot of things, so I'm not sure what to do with that area.
I would probably mark that little one there that you have just had the pointer at.
This one.
Yeah. And
Awesome.
then there might be like farther above
That's
1, 2, right?
that's
It's pretty subtle, but
yeah. That's not very bright at all, but it very well
yeah,
could
but
be.
the geometry is just about right. So I'd probably mark it 2. Here we go.
We're on there. Okay. Cool. All right. Am I missing any others before I move on?
Yeah,
Moving
this
back and
is not
forth.
super obvious. Maybe there's
Oh, what about these?
Yeah, that one's tough to tell. It very well
yeah,
could
yeah,
be.
yeah.
That is probably some people will mark it and some people won't, and that's why we have many people look at each image.
Yes,
Yeah,
totally.
so each image
I
is being
feel
looked at by 20 people before it's retired and put in the archive. So
right. Yeah. So everyone here can feel rest assured that your answer is not going to be the one in the textbook. It's 20 plus of our brains working on it. If this was just me, I would move on from here. Are there any that you would stop me to mark?
is
Everyone
there
good?
is there another one on the left-hand side in the second like white space there? Either this one we just had, this one is a little questionable. There's another one like towards the left on the other side of that white space. Do you see that, Merrick?
Yes, like right to just to the right of where her cursor just was.
Yeah,
Oh,
it's a
sorry,
little
I'll
questionable
stop my
too.
cursor.
So maybe not, huh?
Yeah, that one I think could also
Okay.
go either
Yeah,
way.
yeah, yeah.
All right, I'll mark this one because I can see something there, even though it's pretty faint.
Okay.
Um,
I'm happy with that. Yeah.
All right, I'm gonna go ahead and hit our next thing. So if you're just starting, you have the option to talk about what you just did, or you can just move on to the next one. So if you have any questions, if you hit done and talk, you can also make a note of like, I think there might also be something else happening here, for example, or a question or whatever it might be. And the folks who are super volunteers or our project team will answer your questions, which is pretty cool. So you can start being in the community there. All
And
right, before we move
and
forward.
I want to throw
Oh,
before you go ahead, I want to throw
yeah.
in one information because I just looked at the statistics page and we just crossed the threshold of 20,000 registered participants for this project. We crossed that threshold while we're on this webinar. So thank you all so much for getting us past that threshold and for working with us on this analysis.
That's awesome. 20,000 of y'all across the globe, also a couple Martians on the side, are participating in this. That is awesome. Congratulations. 20,000 is big moment. Think of just how much can be done during or by each individual, right? If everyone participated once, that's already 20,000. Oh my gosh, just a lot of math there to talk through. Awesome. If you were to estimate about how many citizen scientists are marking the arches correctly, says iPhone or ask iPhone. Not sure. We should. What's your or I guess what's the quality assurance threshold, I guess,
Yeah,
that you might make?
so we have quite a bit of processing on the other side of this. We had a student come to JPL and work on a machine learning algorithm that kind of aggregates everybody's identifications together so that for a single arch, instead of having between 1 and 20 points, you have a single point. So it uses what everybody's doing to kind of give us that final location. But obviously, we all make mistakes, so there will be outliers. So if there's kind of one hanging point somewhere off, not associated with an arch, that algorithm's pretty good at identifying those because nobody else marked it in the same spot, and it'll sort of ignore that.
Oh, great. Yeah, that's awesome. So do not worry about your occasional mistakes. Okay, before we move forward, I do want to make sure you have access to a leaderboard. So Roland's going to drop the link in the chat for you to join. That link will take you to the right location. I'll actually show you on the screen too, what that looks like. But essentially, we'll be able to see who's doing the most today, once you join the group. So that link in the chat, when you click on it, you'll be able to see this project. I'm going to go ahead and specify cloud spotting on Mars and let's do custom for today. So we'll look at it for today. Oops, I just want this day. Okay. And so far, and this is based off of whoever was in it with me. So those of you who are with us, let me do last 7 days so we can look at it. So 120 or 102 from someone who already had been a part of this project or this leaderboard. So you better beat that person. All right, so we'll come back to this, but again, that join link is in the chat. I'm going to drop it one more time.
Emma,
If you did do classifications before joining the leaderboard, that's recorded in your Zooniverse account and also in your SciStarter account if you did those instructions at the very top of the hour. So you'll be able to see those too. But the actual comparison after now you know exactly how to participate, now we can see how well you do for the rest of the time with us.
okay, so Emma, just to
Um,
clarify, if we already did like 100 classifications before we joined the leaderboard, they wouldn't be accounted for in the leaderboard stats. Is that right?
no, they will
Okay.
not. You can be in multiple leaderboards though. So if you were in a different one, you might have reference for it
No,
there.
no, I think most people didn't join the leaderboard first. And so I think we've been
Right.
doing a lot of classification. So I think just at the end, when we say, here's the great impact, we're going to have an hour of the event where we were doing it on our own.
Yes. Yeah.
Okay.
This won't be all the classifications counted for Access Science.
Got it.
It's
Okay.
just the leaderboard for fun.
Got it. And then
Yes, there was.
this question has come up a lot. And this is back for the scientists, I think. Why doesn't AI just do this? That has come up several times in chat. So just putting that out there. Thank you.
Yeah, we can answer
Yeah,
that one next. Yeah.
I'm happy to take that. It's a great question. It's actually how this project started. It was my goal to automatically pick all these out. But there's a lot of data, and even if an algorithm can kind of find one of these, and you look at the output and you see that it's correctly doing it, we have 8 different spectral channels where the images all look kind of different because they're at a different wavelength. You need some sort of ground truth to be able to quantify how good the AI is doing or not, or you just have to look at all of them individually yourself. So we sort of realized we needed a large number of identifications to compare with any sort of machine learning algorithm. And that's how we kind of got involved with citizen science. And there's just been so much success of participants finding these that we really haven't gone back to see how those do or improve them at all. I think we're making better progress doing it this way.
Yeah, and we can have sessions like this, where people from the community actually are engaged in the analysis and in the discussion of the data.
Yeah. And the data will all be there. So if someone in the future wants to try to make an AI that can pick these out, they're probably going to be using your data because you've gone through and found so much of this, so many of these. And maybe what it'll be used for is not redoing the work that's been done here, but to find those edge cases like the ones we looked at where maybe a few people mark it and a lot of people don't, and we're not really sure if they're clouds or not. And so maybe something could use the participants' data here to try to map those and learn something about those edge cases. So yeah, there are still opportunities for things like this, but this project has really done so well with the participant classifications that it hasn't been needed.
Excellent. I wanted to pass it back to Sarah to see if we could answer some more of the questions that have been coming in about Mars, Martian atmosphere, etc. Because I know there were a
Sure.
ton earlier.
Yeah, I have an interesting one from the chat. I would like to know which Martian weather phenomena poses the greatest risk to future human missions. Would it be the extreme diurnal temperature swings? So that means temperature swings each day, or the long-term occlusion of solar power, so blocking of solar power due to dust storms. So in your opinion, which of the sort of weather phenomena would be risky to human explorers?
You want to go first?
Yeah, I would probably pick global dust storms, because these are events that have a big impact on the whole atmosphere of Mars. They don't occur every Mars year. On average, somehow every 3 to 5 Mars years we get a global dust storm. But these storms lift a lot of dust into the atmosphere, and it hangs around in the atmosphere for several months, and it becomes really dark on the surface. So if you have solar-powered assets on the surface, you better be prepared to weather that out literally for several months. And this is how we lost Opportunity Rover. Opportunity Rover was lost in the global dust storm of 2018, essentially pretty early on of the onset of the dust storm, essentially by being in the wrong spot at the wrong time. And it experienced several days of very, very dusty conditions and didn't have enough solar power to kind of come back to us. So this is definitely a big effect that we should be concerned about for both robotic and human exploration on the surface.
Okay, and another cloud-related question. Are rainbows possible on Mars? Because we love rainbows. Yeah, so
this is
rainbows.
a tough one, right? Because rainbows,
I guess those would have to be vapor, right? Water vapor.
Yeah, there is water vapor, but rainbows typically require like droplets, water droplets, where the light can go in, get refracted and split up in the different colors of the visible light. And we don't have water droplets on the Mars or in the Martian atmosphere. We might have some droplets on the surface in certain conditions when you have a lot of salt on the surface, but in the atmosphere we don't really have liquid water. We have ice, and ice can create other phenomena like halos or things
iridescence,
like that.
yeah.
Oh, wow.
So some of these high altitude clouds, I think from the rover observations, they've been able to see this iridescence where you have these like mother of pearl type clouds that that do give that sort of rainbow impression, but they're not a full scale rainbow, but they don't just simply look so white. They have a color gradient there associated with it.
Great. Okay, so little bit of that. And Edelman Fossilman Museum was wondering, they asked, so you said ice clouds, but is it water or is it frozen or something else? I think you have actually answered that, but maybe if you can just give them another overview of what these clouds are composed of.
Yeah, so you have water vapor in the atmosphere. And so instead of that water vapor kind of condensing into a water droplet on a particle, it directly freezes from vapor. So you have water vapor, and it requires some particle to freeze onto, and then it can grow. So you get this ice crystal that forms. But the key is there's no water droplet involved in that. It's straight from vapor to ice. And it happens with CO2 as well as water. So CO2 is the primary gas that makes up the atmosphere, but it can get cold enough in very specific locations and times for that gas to actually freeze out as well.
Okay, Dennis is asking in the chat, I missed that one. Did we answer if you can have halos within halos? Dennis, do you mean these loops, or is it halos, the arches, or is it halos on halos in the atmosphere? I'm a little confused about that one.
Arches.
Halos. The arches.
At least Desmond
okay.
had the same question.
Oh, okay, great. So arches within arches.
Yeah,
so was that answered as something to mark if there's like a double arch?
Yeah, you typically won't get like one inside another, but you'll get, this is a good example where oftentimes there will be several consecutive arches in a row, and their legs will overlap, which makes kind of identifying the individual arch peaks a little bit complicated because you're trying to follow the arch legs through its neighbors. Um, but uh, but yeah, this happens a lot, and what you're seeing is so again the orbiter is kind of moving from the south to north on the day side and north to south on the night side, and so these clouds are really close together in latitude. You're seeing one right after another. Um, this is a common feature in the data, and it's something we're hopefully going to start analyzing soon. Is zooming in on just these particular examples where you have multiple clouds in a row and trying to understand why that happens or what's driving it. Yeah.
In this case, since I do have one that's similar to what we're discussing, I'm trying to look at like these peaks as being the edge of each of them instead of trying to decipher these legs. Would that be okay to do, or is that a misdirection?
I think that's the
Misdirect.
right place to start, and then I'd try to follow the legs down. So yeah, this blob you're looking at the top is it could be one or two. So once you find that, then so what my eye sees is the big leg towards the bottom of your image currently. Yeah, that. So try to follow that up, just like the one on the right. Um, yeah, so I'd probably mark it a little bit below where your cursor currently is. Uh, yeah, maybe even a little lower. What I'm also looking at is that you can see that gap, that orange spot. Yeah, so that's probably the edge of that left leg, and then we kind of can't see the right leg. The right leg looks to be in the middle of the arch on the right. So if
Is
you
it
keep
almost like, or for this, it almost looks like these two are the overlapping ones, but maybe I'm like this
Yep,
internal one
I
is
think
really
that's
to the
right.
far left.
Exactly. I think that's right.
Okay, I will mark that. Now, you told me to move down, so we're trying to mark this specifically on the areas that are very bright, right? Like that's the arc
Yeah, that
peak. Okay.
you're good there.
Yeah, and maybe we can go one notch down in the brightness, so maybe that actually helps. So not everything is as saturated.
Yeah, so that makes that dark gap a little bit more clear in the middle too.
Yeah,
Yeah.
yeah, and then
Although
maybe
that
that
makes me
guy
think
too,
it's
huh?
like
The guy
between
in
the
the middle,
two.
that lower guy.
What was that?
I'm sure. You mean on the left?
No, yeah, well,
This?
Yeah. I
that's
think
like
that middle one might be two crossing.
it's too much crossing. Maybe, yeah, maybe it's just the ones on top crossing each other, and that's creating that shape. Yeah.
The deliberation makes me happy because for everyone who's doing this for the first time, feel free to talk to yourself, talk to the people next to you in the room, like deliberate together. It makes a difference even for the experts.
Yeah, take your time and think about it. Ultimately, you have to come to a conclusion one way or the other. But yeah, not all of these just jump right out like that first image we showed.
Yeah. Did you two think that there should be a fourth one marked here based on what we can see here? Like on
I
the
think
far
there might
left?
be one on the left. Yeah, I think that right there might
Okay.
be one.
Okay. Well, for
Um,
that you might make it a little brighter again, huh?
yep, I'd go to one of the other images. Yeah, I think there's enough of that last leg.
Yeah, yeah, kind of like there, right? Yeah, maybe.
All right. I'm glad we had that example. And to answer that question in the chat, a couple of you asked that the question of really close together. It's tough. You have to look through the various different legs. Yeah, good answer. Try to follow each leg down. Look at where you can change the colors to make it more clear, maybe, or undo that. Change the saturation or the brightness of each of these, and just kind of decipher. It takes a moment. Yeah, totally. All right, I'm gonna move away from this. So I did want to pause here. We're about an hour in, so I wanted to check in with all the folks who are in libraries and or libraries and other third spaces that are doing satellite events and just get a good sense of how we're feeling in the chat. If you want to just say, doing good, have questions. Um, if we need help and support for any of this, we're at a good pausing moment. You can also raise your hand, and we can possibly answer some verbal questions since we're about halfway. Right. Well, I see more questions coming in the chat too, so we'll come back to that. I just want to give folks a chance if you're. All right. Thanks, Amanda. Awesome. Amanda, let me know or do a raised hand if any of your folks at the North Webster Library want to ask a question verbally too. I can turn your audio on. Okay. Anyone else from libraries want to say hello? So far, no questions. Everyone's really focused right now. I love it. They're on it. I bet we're going to see some good things in our leaderboard shortly. Starkville Public Library, Brianna, thank you. Everyone's good. Any questions there too? Feel free to raise hand or respond in chat. Right. We have a very particular question about poisonous substances on Mars, and I don't know if we know that yet, Adria. Yeah.
There are
Yeah,
things
we
that,
have a couple of chlorine species
Yeah.
that might be not so helpful, not so healthy, like hydrochloric acid or perchlorate on the surface. So this is probably detrimental to your health if you were exposed to it.
yeah.
Oh man. Well, that's not good. It's a few things. But and then Michael, thanks for sharing. You're a SciStarter ambassador. Good to see you on the list. Learning how to do this slowly. Yeah, take your time. I like talking myself through it. It's a good way to talk to an expert. Exeter Library following, but we got a bit lost. Oh no. Okay, we will help you out too. So as a reminder too, for anyone who needs those instructions again, I can show them, but I'm going to drop the link for the blog, scistarter.org/blog, and it's that first link, and you'll be able to follow and click on links to get to various areas. Okay. Oh, we had a question. Um, would these arches really look like that on the planet, like a jet stream as it passes overhead? Okay, I think we need to talk about the like how the data is gathered again. Would you two mind talking us through that, like how the images? I'll bring that tutorial image back up. There we go. That's the orbiter. So what are these images we're looking at?
Yeah, this is we talked about that earlier, but it's good to go through that again. So Mars Climate Sounder is on Mars Reconnaissance Orbiter, and it most of the time it observes the horizon in the direction of spacecraft travel. So it looks in the direction that the spacecraft is flying to. If you see a cloud on your horizon, you basically can see it from different angles, and these different orbiters on the image here are basically looking at that cloud at different times. So when you're in the position of this first orbiter there, the most to the bottom left, then you basically just see the cloud rising behind you, behind the planet. So the apparent altitude of the cloud is lower than the actual altitude. This will give you one leg of that arch. As you fly towards the cloud, as you keep flying in the direction of travel, at some point you will arrive at the second orbiter there that's kind of in the middle, that has this horizontal view of where the cloud is basically in the tangent point of your view as you look across the horizon. That's where the peak of the arch is. So, and this is actually giving us the information of the altitude. This corresponds to the actual altitude of the cloud. If you then keep flying forward, at some point you will fly over the cloud, and the cloud will disappear under you as you fly over it with your orbiter, and that will give you the second leg of the arch. Essentially, this is how this arch is generated. So it's really it's a feature of the observation geometry. If you were sitting on the surface looking up, then you would probably just see one cloud in the sky, not too laterally extended, because then if it were too laterally extended, it wouldn't form this nice little arch that we see here.
All right. Yeah, it's kind of hard to visualize as a like thinking about this, but I mean, I love this image so that you can at least like the idea of the highest altitude being that edge point looking at it straight on makes a lot of sense to me. So if you're looking at an angle from both ends, like it gets us those lovely magical legs of this. So the more you
Maybe
do
we
this,
should
it
make
makes it
a
more clear.
visualization, like a video visualization, like having the orbiter fly and look.
Like
And like
see,
scanning to
yeah.
build that arch as it goes, that might be a good. Or does that exist already? Are you saying it exists?
It does not exist, but maybe
Oh,
that would be a good asset to have if we
yeah.
have a little bit of time and money.
Yeah. Yeah.
Sarah, you have money for
Someone
that?
send them money, you know. Yeah, that's a great resource to think about once the time and ability comes forward. We did have one question from the folks, and I know Sarah already answered it, but we did have a question from the one of the libraries that I wanted to ask. They were so curious about the opportunity having the ability to come back. Sarah, I see you come back on. Do you want to finish my sentence?
Oh, there's so much love for opportunity and its very long mission on Mars, almost 15 years. So people at that library are wondering if it would be possible to send a rover to fix opportunity, or would it be possible to send a signal to opportunity?
Yeah. I don't know if either of them have worked with Opportunity, but we know it has a dead battery. So is there
Yes,
any
I
chance of
did.
us fixing that battery?
Yeah, I did answer it in the chat as well, but maybe Merrick and Armin want to weigh in on that.
I'm not, yeah.
I know I would probably
These are orbiter guys.
send a new rover that can do what Opportunity can do. I know that if we after the dust storm or after the loss of signal during the dust storm, we spent several days or maybe even weeks to try to make contact with the craft. And yeah, I don't think it's gonna
Magically come
improve
back.
over time sitting on the surface without heating and power.
Yeah, we
So yeah,
got
I think the perspective of fixing it are probably not very high.
yes, and we do recall that that rover mission was supposed to last 3 months, and we got almost 15 years out of it. So it contributed a lot of data about the Mars surface and did its job. And now we move on. We support the current rovers and orbiters in orbit around Mars, and the current rovers on Mars, Curiosity and Perseverance, which are doing great work.
Yeah, which I would love to test out a type of participatory asking a question with you all with a system in a moment here. But since you mentioned it, I did want to see if Armin, do you want to talk a little bit more about like what the orbiter is in your work with the orbiter?
Yeah, MRO, Mars Reconnaissance Orbiter, is a multi-purpose orbiter. It was launched in 2006. In 2005, arrived at Mars in 2006. We actually just had the 20th anniversary of MRO orbit insertion a couple of weeks ago. The instruments have been operating since September through November, like 2006, so almost 20 years now. And there's several instruments on board. There's a bunch of cameras. There's the high-res camera, which is a very high-resolution camera that can give you images of the surface up to like 30 centimeters per pixel. Then coincided with that is another camera that has a somewhat less spatial resolution, but has a wider view. So you get context around your high resolution image. And that's why it's called the context camera. You used to have a near-infrared spectrometer to give you information about mineralogy on the surface. This instrument's not operating anymore because of technical issues. You have a radar that can give you information about the subsurface structure, looking at different layers of rock or ice in the subsurface. And then you have two weather and climate instruments, a weather camera, which is like a wide-angle camera that basically has a fisheye lens and can image clouds and dust storms down looking from orbit. And then you have us, Mars Climate Sounder, MCS, as a thermal infrared radiometer. So it's an instrument that looks at mostly at the infrared light emitted from the atmosphere or the surface, and can measure the temperature in the atmosphere as well as dust and clouds, like we do here.
That is a lot of ability within one like device, essentially one giant device. It's incredible what we're able to do. And by definition, this thing is just orbiting right around Mars. Like it's not doing anything else fancy here.
Well, it is in a low mass orbit. It's the lowest Mars orbit that we've had an orbiter in. It's only over the southern hemisphere. It's only at an altitude of about 250 kilometers. If you had that on Earth, your orbiter would fall out of the sky pretty quickly.
It's not good.
So it's very close to the surface for what an orbiter can do, and that's also helping with getting high resolution images of the surface by the cameras.
Very cool. All right, so we have quite a lot of time left, so I'm gonna pause us here for a moment because we have a special guest I'd like to also introduce and give our friends from JPL a little mini break to hang out and just check in on the chat and say hello, or a bathroom break, honestly, if you would like. But we have an awesome guest with us today. Derek Pitts is here. Um, Roland, would you mind spotlighting Derek so we can introduce him? So just a quick intro about Derek here. Hi. Since 1978, Derek has been instrumental in developing many of the Franklin Institute's public programs and exhibits. Franklin Institute, which I'm sure Derek will talk more about, but it is in Philadelphia. His revitalization of the museum's public observatory, creation of award-winning planetarium shows, my favorite, and his development of community outreach programs has driven audience engagement with astronomy across the region. So not just at the Franklin Institute. A NASA Solar System Ambassador since 2010, in addition to, and we'll talk a little bit about what that means. He just completed a term as Astronomical Society of the Pacific Board President, which is awesome. So very happy to have you, Derek. Hi.
Thanks for having me.
Yeah, we're so happy to have you here. We were curious if anyone in the crowd, I mean, it seems like a lot of them have questions about astronomy and actual Mars related questions, but just to start us off, I want to know like what do you love about your work and what do you think is the most important thing? I guess maybe two different things might be the same, who knows?
Yeah, so sometimes they sort of converge and then diverge again, back and forth. But the thing I love most about my work is when people really get some concept about astronomy or space exploration, and then they become so curious and so interested that they start asking questions themselves. And I think the thing I really love to do is to find the right nugget of information in astronomy or space exploration that will be inspirational to people to follow their curiosity. So I mean, that's a long way of saying I love turning on the light bulb in people about this topic. And the other thing is that I'm ruthless. Any way I can think of to do that, I'll do it. It doesn't matter what it is.
I love it. Is there, I mean, that makes me think, is there a specific circumstance in which you're remembering going 100% to help someone get to that point?
Well, sort of kind of. These days in science museums, we have a lot of rules and regulations, OSHA regulations to keep everybody safe and all that sort of stuff. And I just think back to the days when I used to do a whole lot of floor programs all the time, that some of the things my colleagues and I got away with doing here in the Franklin Institute, if OSHA ever knew, the Franklin Institute would still be closed down.
Oh my gosh. Maybe, I don't know if you can say any of those things in case
Oh
it's
yeah, we used
a
to do
concern now.
we used to do chemistry demonstrations about the chemistry of other planets, atmospheres, and other planets. And the kind of materials that we were creating, combining different chemicals for certain kinds of reactions and all that other sort of stuff. Oh my gosh, we'd still be in jail. But they were great demonstrations and people loved them and they were really exciting and they really got people interested and excited about the stuff. So, that kind of thing. And in Franklin, I don't if any of you know about the Franklin Institute Science Museum. We're a very large, typical hands-on science museum like you're used to seeing around. Franklin Institute, by the way, is, what are we, 202 years old this year. We've been around a very long time. And one of the major features in the building is we have the Franklin Hall, like, rotunda, that is a room that is 85 by 85 by 85 feet, modeled after the Parthenon in Rome. And I think I have that right. No, I'll get the name right in just a second. Not the Parthenon, but it'll come to me in a second. In any case, we
Coliseum?
have this huge. I'm sorry.
Is it Coliseum?
No, 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 not the Colosseum. It'll come to me, and
Okay.
everybody will know which one it is. But we have a huge statue of Benjamin Franklin. It is a national memorial. In fact, I think it's still the only national memorial outside of Washington, D.C. So, like, years ago, during one of the big comets that was gone by, either Yakatake or Hale-Bopp, one of the things I did was I strung microfilament wiring across the top of the rotunda. And my colleagues and I hung planets of the solar system from this filament all around. And we created a comet and we hung that from the microfilament. And we would fly it from day to day, move it from day to day as the comet moves through the solar system. Come to find out later that this was like a completely sacrilegious thing to do to a national monument kind of thing. But, for the sake of informal science education and getting people excited about science, what's off limits? I don't know what's off limits. So all
Yeah,
kinds of
I feel
fun
like that's
things.
a nice way to engage the monument in the learning. It could be seen on
Exactly.
a very deeper level.
No, of course. And I'm sure Benjamin Franklin would have loved it.
Oh, absolutely. As a first member of our citizen scientist community in early America, right? Like he mapped the Gulf
Exactly.
Stream with the use of a cousin and friends. Like there's a lot that he is a part of in the citizen
A
science history.
lot. Yep,
Yeah,
that's right. Yep, very true.
totally.
Yeah.
I did want to ask about like what you're up to now and what you're excited for the future of informal STEM learning or the work you do at Franklin Institute, or just in general. It might even be about Artemis too, if you'd like. But what's happening?
Well, one of the really cool projects that I've been working on for the last couple of years is creating astronomy outreach programming to that couples informal science institutions, community centers, and amateur astronomers. And I've done three different versions of this now with NASA funding to support this. Thank you very much, NASA, for all the tremendous support that you provided for this, because it's allowed us to introduce uh, underserved audiences. Now, underserved is typically a code word for people of color, but in this sense, underserved means people that live in urban areas that don't have access to the night sky because city lighting is too bright, or underserved in that they simply haven't had very much introduction to astronomy at all, et cetera, et cetera, et cetera. So I particularly focus on these underserved audiences, figuring out ways I can connect them with astronomy right in their communities so that they understand that you don't have to go to the big building downtown. You don't have to go to a research institution, but the universe is right above your head. And even if you're in an urban environment, there's still a tremendous amount of stuff that you can do that will connect you to the night sky in a meaningful way, and also stimulate curiosity and inspire, a passion for learning about science and technology, particularly astronomy and space exploration. So that's been a fun thing to do because we've been not only engaging community centers, the community-based organizations, and this is everything from boys and girls clubs to churches to libraries, as we, so well know. Libraries have been such great partners for us all across the board, and it's been a really great opportunity for us to make much better connections with the community-based organizations in a way that's really meaningful, in that rather than us telling them what we're going to do for them, we create an environment in which we actually work together as true partners. We have this resource here, you have that resource there. How can we put these resources together to the mutual benefit, to our mutual benefit, and at the same time, introduce all of our audiences to the night sky in a really meaningful way? And then the other piece is bringing amateur astronomers on board. Oh my gosh, this huge community that is so rich with experience and knowledge really can do a tremendous service to any of these communities by figuring out ways that we can all get together to share our knowledge and experience. It expands the capability of amateur astronomers. It brings the resource to the community centers. It helps the big science museum create better community connections and have more meaningful impact, all those kinds of things. So I love doing that on the local basis. I've expanded it out now to national reach, and we're now working on creating a essentially what's like a program that will be used in boys and girls clubs to help generate interest in STEM STEM fields through heliophysics. That's also almost like a workforce development program. And this is particularly important considering that NASA's sort of change in strategic direction around education has been that they're pushing to bring skilled technical people into the fold of the NASA workforce to help build rockets and stuff like that. And so we want to help get that message out to these communities so that they understand that there are tremendous opportunities in both STEM education and STEM careers at NASA as well. So that's some of the fun stuff. And of course, always looking for opportunities to get out in the street with a telescope and turn people onto the night sky.
Yeah, which I'll actually tell everyone about a nice upcoming event that you'll be a part of in a week or so soon here, but I'll close out with that. So before then, there were a couple questions about online programming via the Franklin Institute. So not everyone is with you out in Pennsylvania. So curious, what would you recommend educators look into or just regular volunteers and folks who are curious about informal learning for themselves and for others?
Curious about informal learning for themselves. Well, so, and I'm sorry, did you say other than science museums?
Oh, sorry. No, I meant if the I spoke really fast. The Franklin Institute has online programming. Since we're not all out in P Pennsylvania, what would you recommend to folks who want to get in but are not close by?
Hmm. I,
Google
I'm sorry.
Franklin Institute first.
So
Um,
I'm sorry. I'm not quite understanding the question. Can you say it one more time?
oh, uh, le, what sorts of online programming is available via the Franklin Institute these days? Any educator training and other?
Yeah, we do. We do a lot of professional development training work, and I believe that you can find links to that on the Franklin Institute's website. If you go to our website, go down to the bottom and look at the menu selections at the bottom, I think you'll be able to find quite a bit of the material that we have available online for a lot of the programming. In fact, we still have a batch of programming online for our most recent not our most recent, our just past NASA outreach program called Mission to Mars, in which we have a whole suite of materials that we created, believe it or not, to dovetail with the Artemis program as NASA proposed it about 5 years ago. And the idea was that we would couple the development of NASA's Artemis program with the last best apparition of Mars, and it all went south when COVID struck and that we couldn't quite get everything lined up. But all of that content and material that has a lot of activities built for community centers and stuff, that's all still online. And so you can go to our website and check there.
Awesome. Okay, good to know. We got a question from Jack asking about what your absolute favorite thing has been that you've learned or seen since you started studying astronomy.
Oh my gosh, you mean I have to pick one thing? That's
We
really
can assume there's
tough.
many if you pick one that's just off the top of your head.
Sure, yeah. Okay, so I guess I have two. Um, so first of all, there's no question about it. What I really love, absolutely love, is how the complexity of the universe actually creates a stunning beauty. And as we look at all of the objects that we see out in the universe, the galaxies, the nebulae, the black holes, the stars, the planets, all those things, the forces that go together to create the universe also make all of this gorgeous stuff that we see about the universe. And I just love how it all dovetails together in that as gorgeous as it is, it couldn't be without the forces of the universe that make it the way it is. And then what I love to do is I layer on top of that, as humans, we have these two detectors right here that allow us to perceive that beauty in the visual sense and really appreciate that with the visual receptors that we have that are tuned to this particular environment with this particular star. And then on top of that, I love it that we've got this thing up here inside our skull with which we can learn about and interpret as much as we've been able to about the universe so far, and that it's accessible to anybody that really wants to learn about it. And then I guess finally, the thing that really takes me out, really stuns me, is I love going outside at night, looking up at the night sky, and being able to see, and this just gets me every time. I love seeing International Space Station fly by. I just love seeing International Space Station fly by. For as many times as I've seen it go by, or seen Mir Space Station go by, or any of those kinds of things, and I think the thing that does it for me is, I'm a big motorhead. I love knowing all the technical details about all of the space equipment. But I think the real thing is my realization that there are people up there. I think that's the thing that gets me is that there are people up there, and we all know that people have been living and working in space for the last 25 years. But outside of all the technical stuff, I just feel connected to those intrepid explorers that are willing to take such a huge risk to push the envelope of human curiosity by being willing to get in a can and fly around the planet for a few months at a time. And I look up and I want to wave. I know they can't see me, but I want to wave just to express my admiration and appreciation to them for, as being human, carrying a little bit of me along with them as they explore the universe, as they extend my curiosity for me through them. And and then I guess the little side thing to that is I love to teach people how to see space station for that reason.
I hope there's a crossover at some point on the 13th at that event we'll talk about shortly. That would be
Hey,
awesome.
it's this one fact about this gets me, and I think this is true for a lot of other places. But I learned that space station flies over Philadelphia between 4 and 7 times every day.
Oh, what? Okay.
Every day, right? And of course,
Perfect.
of course, us sky observers know that most of the time it's not visible. It's only visible in that sliver of pre-dawn and post-sunset. But the rest of the time it's still up there. So they're always there, And
Mhm.
that just floors me. Anyway, that's the stuff I like.
I
And like you
love
said,
it.
there's a thousand other things. Oh my gosh, the universe is full of so many other things.
Absolutely. To kind of close this out a little bit here, I'm going to expand a question that Dennis, one of our moderators, who's also a solar system ambassador, asked, which is for people who live in urban areas such as Philadelphia or New York City, are there options for training potential astronomers given the challenges? And I want to add to that of like any advice in general that you would give to people who are interested in just learning more, either professionally or just for their own fun.
Yeah, sure. I'll start out with this fact. I've been here at Franklin Institute for a very long time. I spent so much of my time working in the observatory here, and the sort of sideline number that I've come up with is about, and we've done a lot of night programming in the observatory. Bring the public in, let them look through the telescope, blah, 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 blah. We have a nice 25 centimeter size refractor, works really well. So, here's the number. Somewhere between 80 and 85% of people that come to the observatory have never looked through a telescope before. Okay? Wow, that's a lot of people. On the other hand, we're right in Center City, Philadelphia. So what can we see? The moon, if we're lucky. I'm kidding. We can see the moon, but we can also see all the bright planets and all the bright stars. So what this does is this defines for us this little narrow slit that we work in. If 85% of people coming to the museum have never looked through a telescope before, and we can show them the moon or Jupiter and Saturn, their experience viewing Jupiter for the first time, I would contend, is no less important or significant than Galileo's first look at Jupiter through a telescope because it's a discovery experience for them. Okay, you see what I mean? So, what I think is the opportunity, even in the Center City environment, amateur astronomy clubs and organizations have this unique opportunity, along with science centers like ours and other informal science organizations, including community-based organizations, have this really wonderful opportunity to introduce a very large segment of the population to the night sky through the moon, Jupiter, Saturn, Venus, Mars, and the bright stars, even telescopically, even though your skies are very, very highly compromised by city lights, because those objects are all visible. And to look at the moon on a really good night under decent magnification is incredibly illuminating, pun intended, because there's so many great details on the surface of the moon that can be seen. But you can also look at the phases of Venus. You can look at features on Mars. You can look at how the moons are orbiting Jupiter. You can look at Saturn and its rings and the moons, and you can do all that kind of stuff. And so many other things you can do with variable stars and multiple stars and so on and so forth, like that. There's a whole universe, again, to use the pun, of things that people can be engaged in just to get their juices of curiosity flowing so they can then go off and do more on their own, maybe at a location where the sky is darker, but they can learn how telescopes work. They can learn how the sky is set up. They can learn what they can look for, and then they can get started on looking for those things on their own after they've learned just that little bit.
It was beautiful. I love the puns. And I'm seeing so many people just sending in like nice commentary and extra resources related to what you're talking about. So thank you so much for giving us a lot of inspiration too about the space and getting engaged in all kinds of ways, professionally, for fun, doing citizen science, etc. For those of you who are interested and available to and able to do so, you can also meet Derek Pitts in Philly on April 13th at a Dark Sky event as a part of Citizen Science Month. So come on down. And that link that Darlene had put into the chat is the one to go to find out more. It's not just about space, it's also about looking at light pollution, which Derek mentioned, and bird migration too, because we have a lot of birds crossing over the country and they don't, for lack of better terminology for this, they don't all make it because of light pollution impacting the way that they transport and they hit windows and all kinds of stuff. And so if you want to get involved in some of those things, we have an option for you. We also have a website for more information about that too. Darlene, if you want to write in the Safer Sky or Dark Sky Safer Fly website, that's also related. Thank you so much, Derek. I'm really glad we got to meet you and chat with you. And hopefully we'll see you back for more SciStarter events in the future. Thanks so much.
Thanks, Emma. Thanks, everybody.
Awesome. All right, for everyone who is hanging out there and doing cloud spotting on Mars still, let's come back to that too, because we still got more time to do more acts of science and get the test tube limit up to 2.5 million. It's only 2 days in, so I don't think we'll hit that 2 million yet, but we can at least get ready to do as much as possible. So I'm going to check in on our group to see how we're doing, because I think we have a lot of acts of science done. And I can tell you the total for the group. Let's see here. Oh, of course, it's asking me if I want to save my classification. Here we go. Our group. For anyone who knows or who wants to know how to get to the groups, by the way, I'm going to go and show you that because it's if anyone does not have the same intuition that you might need. So if you go to your home page, which when you get here, you'll see my groups, and I'm going to go over to SciStarter and do NASA Science Live, which today we have a lot in here. I want to see classify on Mars specifically, and today, that's not today, last 7 days. And today we have over 1,000 over 1,135. That is incredible. Excellent job, everyone. Thanks for those of you who joined the group too. And that's probably not even all of us. So for all the acts that are coming through, I am curious, Merrick and Armin, I'd love to know soon when we get to closer to the end of the event. We'd like to know how many or how much we pushed up just ballpark and what that really means for you. So we'll kind of prompt that conversation later on. I will get back to that project. And for those of you who are in groups and just want to share a little bit about how you're doing too, I did want to check in to see how we're feeling about the data. I know a lot of you had already started, so if this is like, yep, I'm good, we're running. I'm curious how we're feeling about the access sign or sorry, the classification of the data. So I'm gonna change my screen and kind of test the scenario with the group of us we have here. If you are in a room looking at a big screen or if you're looking at a computer, either way, you can use this QR code to answer this question and others. And I have some fun other questions to share with you before the end of today too. So if you'd like to participate by sharing your thoughts in a room, you can do this independently. It doesn't have to come from your facilitator. And so if you'd like to join, I already see a bunch of you joining, and the numbers getting bigger. Thank you all for being so quick to scan QR codes. If you are on a computer and just want to click a link, I'm also going to give you that ability, which I can do momentarily. Where are you? Whoops. I want the link. Where'd that go? I must have turned it off. If you go to menti.com and then type in that link, I will send menti.com into the chat for you. Oops. Menti.com. Yes. Okay. Oops. All right. So in the chat. Oh, thank you, Roland. I have too many things open. Awesome. Okay. Yeah. If you jump to menti.com, you can also type in 55159175 and answer some questions for us. So our first one here, what do you like about cloud spotting so far? How are you doing? How do you like it? I'd like to help science projects, being a part of something greater, love it, learning something new, fun, a little bit tedious. You are doing one task, that's true, but that's why it's evolved. You can do shapes next. Never seen this stuff before, so it can't be too tedious yet. I like how easy it is, but so cool at the same time. Yes, absolutely interesting. Easy repetitiveness. So even you might really like that. It's an easy thing to just jump into and keep doing. Fun reading about what others think and sharing opinions. Engrossing and easy to do. Feels great to be able to contribute. I've never really been interested entirely in astronomy, but I feel like this event has really helped open my mind to everything that astronomy is and why it's special. Yes, that's why we're here. I mean, that and also helping science move forward quicker. Learning something new and participating. It's unique, fun, advances science. Who doesn't love learning more about the red planet? True. I love learning more. Does anyone have a favorite planet? You must answer as Mars, comma, your other planet if it's different. I like how easy it is to identify, learning new information about how clouds form on Mars. I mean, I don't know about you all, but before I knew about this project, I didn't expect Mars to really have clouds, period. So if any of you were in that boat, that is fun. I like classifying things and learning about Martian clouds. Interesting. It's a fun challenge. And if any of you are thinking, like, this is fun, but I don't know if I love it for the long term, don't tell us now, because we'll be sad. But I do want to note there are so many projects that you can participate in too. You can absolutely use this as an opportunity to just explore everything on SciStarter and just find what fits what you want. And so if this is like your starter, your spark bird for the birders out there, I hope that this is one of those moments for you all too. My friends Armin and Merrick, what are your favorite parts about this project? Is there anything that comes to mind?
For me, it's been getting involved in citizen science. I didn't know this community existed before we kind of went down this path, and it's been really eye-opening, to see everybody online today, and we've gotten to do some webinars where we meet some of the participants as well. Yeah, I mean, we we obviously love the science and are really interested, and what we can learn about Mars from this. But it's been cool to interact with everybody who we wouldn't have known was interested in this.
Yeah, absolutely. Armin, anything different?
Yeah, I mean, this is a great aspect of this, and uh, and in addition, it's great to see this data being analyzed in this way, because we saw these arches already basically within days after turning on the instrument. And in the beginning, we didn't really know what it was. So we were struggling for several days and weeks, speculating what this could be, until one of my predecessors kind of had the idea what here, maybe it's really just clouds and geometry like turns it into an arch. So we've been aware of these arches for a very long time, but it's always it's been a struggle to kind of like really analyze it because it's so much data and there's so many arches. So having this crowd of people looking at this has really been a game changer. So we can really do statistics with these clouds now and get like real science out of it. This is what I think is fantastic about this.
Yeah, I totally agree. This is just such a big, lovely community to be a part of, right? All these citizen scientists really helping do real work. Um, and feeling good about it too. For how confident you're feeling about working with this data, I just want to do a temperature check. We'll do some more examples too. And so you can get a little bit more confident for those of you who are on the lower half of the scale. I appreciate some of you creating the scale for some of you. So I like where we're sitting. We're pretty confident, relatively starting fresh. So sometimes that's tough. And it is, some of these are pretty tough. So you might have noticed me refreshing the screen to find some examples too. So let's go ahead and I'm going to go ahead and jump back to it so that Armin and Merritt can help us do a couple more for those of you who want some more examples too. And we'll be on our way to closing out and looking at our final results. All right, so oh, I'm actually going to stay here. For those of you in the chat, if you see an arch, put arch in the chat and send it. Do you see an arch in my screen that you're looking at on the Zoom? Do you see an arch? Yay or nay? Can write
Sounds pretty
arch. You
visible,
can say
Jane.
yes, either one.
I think we should point that out.
Oh, I have some specificity here. Do we agree? I think so. Okay, awesome. We see yeses, we see more than one, and one of you says towards the center. So let's take a look. I totally agree. This is towards the center is my assumption. And I see several. Oh, look, that third one really helped. All right, I'm gonna go ahead and zoom in and we'll test how well I do this. I like here. Oh, I'm actually gonna mark this other one first because it's harder to see. So the one behind this, the one here, I saw at least those two. Let me just kind of scroll around. This might be two legs, so I'm gonna look for the top of it. Oh, whoa. Ah, Armin and Merrick, can you help me out? This one looks like it's just one line of dark, right? There's no top to that arch.
Yeah, I
That's a
think
Oh,
difficult one, right? Yeah.
I think that's a little bit of an artifact of the data. There's a
what
lot of
does that
noise
mean?
kind of in
What
the
is
in the top part of this image.
okay,
I would go back in the contrast actually here,
okay.
and maybe even one more.
Can do.
Yeah,
Yeah, you see a couple here already.
Are you looking at these two?
Yeah.
Oh wow, okay. I hadn't even thought to look in where it gets a little noisier with the rest of the atmosphere. I did see someone ask about like the bigger white spaces at the bottom there, and that is the upper atmosphere, right? Or like more atmosphere interference.
Y-
Um,
yeah. So like this blob that you're looking at is the lower atmosphere. So these arches that you're picking out are a little bit lower than the high ones. So those high ones might be 60 kilometers. These might be 30 or 40 kilometers. So still
Ooh.
close in the middle atmosphere, but you're seeing the bulk of the atmosphere below. Um, and uh, and one other thing that you can, this looks different than other images that we've looked at because there are these huge dark spots on either side of the
Right, yeah.
atmosphere. And that's because this image in particular is from our visible channel. So uh, we're looking at visible light which means when we're on the night side, we don't see anything. We don't see the lower atmosphere because
Oh,
there's no sunlight to for us to to be able to see anything.
right. Okay, that's so cool. So we're on the like the dark side of Mars for a moment.
Yeah, and
It's
if you're
nighttime.
interested in any of those details, there should be a button somewhere. Oh, in the bottom left below the one times drop down menu that says subject info. So actually below the yeah
Oh, ooh, okay.
yeah, this has like some metadata that is a little bit uh, isn't immediately obvious what it is. But what I was talking about there, so it actually tells you what channel you're looking at, and that A6 is our visible channel. So anytime you get an A6 image, it'll look something like this, where you won't see the any data on the night side.
Interesting.
And
Well,
then
okay.
so
Oh,
there's other information that we can talk about, but it's not so important for the for picking the images out.
yeah, if folks want to keep exploring too, as we had mentioned before, the done and talk, if you want to share something about it, that side of it too, if you go to the talk boards, there's a lot of information there for you to look through and what people are talking about regarding this project. So I have no doubts that you can also just build entire conversations if this is your Spark project. Please do so. Make some friends. I'm gonna zoom in again and see if I missed any over here. It's wild to see some like slight indentations. I'm nervous to mark this, but I feel like this is an example of the lower atmosphere, but it still qualifies as a cloud.
Yes.
Um, okay, cool. I get to be the unsure one. Everyone else has to do it on their own. I get assistance from the crowd and the professionals. Were there any others in there actually that I missed? Anyone can
Was
mention
there anything
or
like higher up in that stretch?
let's do it backwards.
No, maybe not. Yeah.
I mean, I see some potential legs, but it looks almost like it's an offshoot of this one. So I'm not sure if that's
Yeah, that's
all.
difficult down there.
Yeah. I could try changing this. Like, could there be one right here with two legs?
There might be, yeah.
I don't know. I'm not sure.
Photo market. I feel like that might be something
Yeah, that
good. And
might be legs crossing.
Yeah.
But
then I'll
Maybe
do
not.
some slow crawl over here. Oh man, this is really confusing me right here. The very
yeah,
strong line. It's just so
uh,
exact.
yeah, I'm not sure exactly what that is, but I wouldn't mark it just because there are a lot of times where you'll sort of see these parallel streaks. And
Mhm.
if you can't see them connect into an actual arch, uh, it's probably
I'll
best to
just,
not mark it. We
it's a
have
Martian
one
fly
field
hitting
guide
orbit.
example that shows some of those in more detail. Um, but they don't look exactly like this one here.
Gotcha. I do see a question about the group in the chat. Roland, would you mind dropping that link again? There's also a Go link that I had dropped earlier in the chat that's quicker. But Desmond and anyone else who's asking, when you click on that, it is the join link. So as long as you're signed in, it'll have you join it when you click it. So if you did already click it, you might already be in the group and you just don't realize it yet. Um, yes, but we can try to help however we can there. We could even look for you too if you add your username. Awesome. All right, I did not I mean, I see maybe something right here, but it's so faint, and when I make it bigger, that's scary. So I'm trying to see. Oh, maybe that is connecting actually, but there's no bright spot at the top. Might be. How do the experts feel about this?
Yeah, I don't know. Maybe not. Maybe
Maybe
not.
not.
Like, let's try not to overdo it.
Yeah, those look a little parallel, and you see that a lot at kind of the top part of the bright areas where there'll be a lot of streaks. So try to avoid streaks.
Okay. We will avoid the streaks. All right. I'm gonna pause for a moment. Sarah, did you want to ask a question from the chat? Sorry, you jumped in. I wanted to.
Sure, I did jump in because when you were looking at the data, someone is asking, what is the other white noise in images that aren't arches or clouds? So is there Can we describe what that sort of noisy data is? Is it something?
I'm not quite sure what people mean about noise. I mean, there's the radiance that we get from the lower atmosphere. This is in the visible channel. This is like scattered light from the sun on dust particles or things like that, or in the infrared channels, it's emitted light from dust in the atmosphere or from the atmosphere itself. CO2 gas can emit light too. If the question is more like about when you stretch it really far and you have this, this noise coming up on the top there, this is just noise. These are, this stuff here, yeah.
This stuff?
These are sensitive detectors, and the zero is not always exactly zero. It can wobble around a little bit around zero. So even though we calibrate these pretty well, there's always some noise on the detector, and if you display it like that, you can see this this dark blue hue in the background that indicates that the detector is and the measuring black space, but it's not completely zero.
Got it. And someone had a cool question. Are there any other or unexpected discoveries made by volunteers in your project?
It's a good question. One of the difficulties for this kind of citizen science project, where the goal is really to do this statistically. So it's not too surprising that we see clouds in a lot of the regions where they get picked out by participants. But what we don't know anything about is, or just getting a handle on, are how many are in certain locations at certain times. One thing I will say is that, well, so it's hard to look at one of these images and sort of make a discovery of a new phenomenon. But having now having participants look at multiple Mars years now, we've seen that people have identified arches in places where we didn't actually expect them. So there's a class of very high altitude, like sort of at the top of where our data cuts off in these images, in that visible channel in particular, where it's sort of on the night side. So these clouds are like kind of noctilucent clouds that you can see on Earth when the sun has sort of set already, but there's ice high in the atmosphere, and the sunlight hits those and reflects down onto the night side, and you can see them. And we found a number of those. I shouldn't say we've noticed that participants have found those. And we're trying to understand those a bit better, but they were in kind of a location in this visible channel that we didn't necessarily expect.
Yeah, well,
And
it's wonderful that projects like this are giving you a new understanding as well.
Yeah, and there's some interesting details with those too. We see those in these kind of larger dust storm times. And so we think what it's showing us is when that dust picks up, when those dust storms really affect the planet, they heat the atmosphere, they change the circulation, and they push some of this water vapor to really high altitudes in the southern hemisphere. And then when that water vapor gets high enough, it gets cold and then freezes into these clouds.
I have one more question because it just came in, and I think it's a cool one. Could this kind of data help some of the future human or robotic missions on Mars, for example, for the Mars helicopters?
I think so. Yeah. Do you want to?
Yeah, I mean, I think this data set, together with other data sets of the atmosphere that we gather at Mars, will help improve numerical models that will hopefully put us in the position to at some point do some kind of like a weather forecast on Mars. So this data set in particular really aims more at the higher atmosphere. So this is not the altitude range where your helicopter would fly, but it does help us understand how an atmosphere functions, right? How an atmosphere works, what the dynamics is, how air masses get moved around. So in the big picture, I really see this as a contribution to better understand the atmosphere, to improve the models, like global climate models that can simulate dynamics in the atmosphere and make them more robust. So at some point, we'll be, and I hope this will be not too far in the future, where we'll be able to to take the model, ingest data to kind of like tweak the model a little bit, and then let it run for a few days ahead to get something like a weather forecast that we're used to on Earth. And yeah, maybe the astronauts, once they're on the surface, I would like us to be in the position to provide the information on the weather app, when they go outside of their habitat in the morning, to know whether a dust storm is coming or not. So I hope we will be there not too far in the future.
It's very much like The Martian. I'm gonna have to close this out in a couple of minutes here, so I'm gonna go ahead and move us in that direction. For anyone who's a part of a library group or anything like that, feel free to raise your hand. I'm gonna open up videos in a little while to do a group picture at the end of this. You can also do it if you're an individual, but we're prioritizing our folks who are a part of our satellite event hosts. For any of you who are like, oh my gosh, this is great, I want to continue later, but I'm scared about not knowing what to do, we got your back. I have this lovely flyer that gives you a reminder of how to get set up at home, and then also just the basics on participating. So if you want to look at this later on, please feel free to do so. Everything is also on that scistarter.org/blog page that you can look at. It's the entire agenda. It also has information about the Franklin Institute. It's got it all, so you can go back to that area if you'd like to learn more. We didn't have a chance to talk about it at length, but I did want to just point out real fast and thank the moderators who are with us, who are part of the Solar System Ambassador group through NASA. Sarah, do you want to just do a quick shout out for who they are and how awesome they are?
Sure. So these are NASA volunteers. We have over 1,000 volunteers across the country, and they're wonderfully dedicated people, have been very active in the chat, both answering questions and asking their own questions, which of course gets a whole bunch of neat dialogue going and gets all of us thinking. So just a short list is Dennis and Lori and Adrienne, and I saw Liz, calling them by their first names, but they're all over the country. And we appreciate them sharing this with their audiences and sharing their enthusiasm with science right here today.
Yeah. And if you'd like to join the SciStarter Ambassador crew, you can become a SciStarter champion at any moment and later become a Solar System Ambassador and a SciStarter Ambassador if you'd like, or apply to be one anyway. There are a ton of ambassadors to the SciStarter program in the chat too. I want to point out we got Desmond here, we got Desari, we've got Keith, we've got Gary, I believe, Heather. Oh my gosh, yeah, there's so many of you in here, and I'm trying to make sure I'm naming the right people. Lakitra, thank you all for being here and for joining us. Rachel, I was reading in alphabetical order. We love you all, so thanks for being with us. I'm going to also leave this with you. If you would like to tell us how we did and how to improve these, we'd love to know. If you're an event host, you'll also receive an email from me about telling us how it went and how many folks you had, so we can make sure all of that counts towards our 2.5 million acts of science end goal for the month of April, which I just wanted to point out during this call, we just contributed a ton to it, and I'll be adding in a special count for today's event. But just to give you all a good view of what we've accomplished within 2 days, we're over 160,000 acts of science. So we're well on our way to our goal. So thank you all for being a part of this. Thank you so much, Merrick and Armin, for joining us and talking with us for these last 2 hours. We learned a ton. There's still more questions, so people might come back to our later session to ask them again. Feel free to, by the way. And
Yeah,
we
thanks
can.
for having us, and thanks everyone for participating.
Yeah, this has been a great event, and we had over 100 participants, I think, online, and that doesn't count people who were joining as groups. So I think
Yeah.
it's really great to have this event and be able to bring that kind of science out to the community.
Absolutely. Yeah, thank you so much for guiding us through that process. For any of you who just want to answer a fun question before you leave, we didn't have time for all of them, but in case you want to leave with a last note of what you would do if you were on Mars for an extended stay and looking at your weather app, what items would you bring with you? Feel free to leave us with that lasting note before you leave here today. It's on through the Menti again, if you'd like to answer from wherever you are. And I'm loving all the comments in the chat and sending all the love. And all right, let's see if I can figure out to all my friends who we listed as oh, I don't understand that question. Sorry, Desmond, can you say that one more time? And I'll help you with the group as well after this when we cut the recording and all. Alrighty. Cool. A book. Someone's bringing a book. A piece of soil from Earth. Yeah, feel free to add it in the chat. I realize people are doing that. We'd bring DVDs. ACDC. All right. So CDs. Great webinar. Yeah. Thank you, everyone. Add our cameras. Yes. Okay. I'm going to go through and add the names I recognize. None of you raised your hands, so I wasn't sure what to do for y'all, but we can make Roland, if you recognize names, we're going to add these folks to panelists so they can say hello. Yeah. Panelist. There we go. I know you. Maybe you just didn't know how to find your hand raise. That might be why. You're also, if I promote you to panelist and you don't want to, not to worry, you do not need to turn your camera on unless you want to. It's up to you. Come on, there we go. Working on as many names as I can. Let's see. Thank you all for being here. Ah, the names are moving too fast. Hi. Oh, my screen is too small. We also have some great answers here. Thank you all for doing that.
Looks like Desmond too. I know he did not raise
I
his
clicked
hand,
on
but
Desmond already. I think it's
hey,
loading, but
Desmond. Thank you. I love all
Mary,
these
there you are.
release too.
Rachel, where did you go? Your names keep moving.
Well, Desmond had to rejoin. Darn it. Desmond, later on, I bet Roland can email you to figure out. You probably maybe have 2 accounts or something. I had 2 accounts.
Yeah, we can figure that out.
It's pretty incredible how many acts of science have taken place already since yesterday. What'd you say, Emma? Like 120,000 or something?
Last night, the last time I checked before I was asleep anyway, it was in the 90,000. But this morning it went up pretty quickly.
Yeah, I think you just mentioned it. Let me look online.
Right now? Oh, yeah, I had it on the screen. 161,000.
Yeah. Yeah, that's
Yeah.
great. And we should mention, Emma probably did. It can take up to 6 hours for your contributions, your classifications from Zooniverse to appear in your dashboard on SciStarter, which is also when you'll see the needle or the thermometer jump up. So you'll see this number jump up. It just kind of makes its way through a system.
Yeah, and then you get to see how impressive you are over the time. All right, I'm gonna stop my screen share so we can see more folks. For those of you who are on camera, Lakitra, do you want to say hi? How are you doing?
Doing well and having fun competing against everyone. I mean, doing the exercise. Sorry.
I love your shirt. I haven't seen the robot with the or what is it? A sticker? What do you have on your? Yes, the ambassador.
It's a shirt.
It looks great. It looks great. Thank you for wearing that. And you do too,
Emma, I
Desmond?
couldn't figure out video earlier to show you everyone who was here, but Farmington Library had a great crowd. They had a great time.
Oh yeah, that's
I'm
great.
glad to hear it.
We'll
I
try
have
that
to
in-
promote you to panelist next time, so I think you're joining for another one, so we'll just make sure to prepare for that one because I don't see your hand raised apparently, so I have to figure out how to fix that. Thanks.
Yeah, we've got a bunch of people who are coming back for the Earth Day one. They were thrilled.
It's great.
Yay!
We did this
Awesome.
early.
Any difficulty getting started? Feeling good? Oh, sorry, I might have talked at the same time as Darlene.
The only thing that we struggled with was just everybody wanting to get their account set up before. I think we'll just encourage people to come a little earlier in the future.
Okay. Awesome. That's really good to know. Okay. Darlene, sorry, what were you going to say before?
Well, two things. One, we might want to do the camera before so everybody can say hi to each other. I think it's just amazing to see how many people are in these in-person groups. And then also, how do we get everybody on now to do like a group shot? Is there a way to orient the so it's not all just one line? Sometimes I've seen it where it's just the screen. So anybody
All
know how to do
one line. I
right now?
stopped my screen share. Is it?
It's you, which makes sense. But if you were to do
Oh my-
like a screen grab or something of everybody,
Yeah, it's gallery mode right now for me. I might be spotlit though. Let's turn me off of spotlight if that's the case. Um, Hopefully I'm not
thank you.
actually.
That's more people.
Hey, Armin and Merrick, can you separate to your two group or to your two computers so we can see your faces closer?
Sure thing.
Okay, I'm not spotlit, so it must not be in, it might be in speaker mode for you. Either way, I'll take the picture so you can do that. Let me see if I can get more people online first, though. I'm marking everyone as possible as panelists, so please say yes when you get it.
Yeah. And you were right, Emma. I had to do gallery view. Now I can see everybody.
Yeah,
Thank you.
I was like, I stopped sharing. Hopefully that fixes it usually. All right, I did ask a bunch of you to become a panelist, so some of you are just not joining us, and that's totally okay. Yeah, okay, sorry for asking you multiple times then. My bad. Oh, I just hit allow to talk for someone. That's not what I meant to do. Uh,
I'm
all
very
right,
impressed
for my
that 50 of
international
us are
folks.
still here after 2 hours. That was pretty good.
Yeah. Uh, okay, I think that might be all we're gonna get because I'm getting a lot of declines, which is totally okay, not to worry. Mary, I'm gonna mute you because my audio is coming through on yours, and I'm not sure why. Okay. Great. All right. For those of you who are on as panelists, if you're able to turn your camera on, that'd be great. I'm gonna go ahead and take a screenshot, give a smile or some peace signs, whatever you'd like, or alien motions. Yes, thank you, Werner. That's what I was looking for. It's not an alien motion. All right, there's one. Here's your second chance. Um, oh, Mary, do you need a second to turn your camera on then? I'll wait like 2 seconds. One, two. Three, two, one. Oh, come on. Someone's in the way, or something is in the way. My bad. All right, let's try that again. Three, two, one, smile. Very good. Awesome.
Yay.
Thank you all for staying after to hang out and chat. I'm going to close the webinar in a moment. Any final words from our special guests or Darlene before we close it?
Just thank you, Emma. You did a great job. And thanks for all the hosts who joined us. And for our two project scientists, that was really incredible. Thanks for sticking with us for the whole time. I hope you see a bump in your research too. And we have part 2 of this, at I think 9 p.m. Eastern time. Is that right, Emma?
Mm-hmm.
We're doing the
Yes.
same thing again. So it'll be, maybe not as many people on, but I saw a lot of activity there on your project. So thank you, everybody, for tuning in. And thanks for the feedback. Thank you, Emma.
Thanks, everyone. We'll see you
Yeah,
at
thank
9,
you. Really
probably, right?
appreciate
No.
it.